Let's go, Ross! Woo! Woo! You're a legend!
That's probably the greatest program I've ever had.
Yeah, thank you.
Awesome. So tonight I'm going to be talking about how to get mean with Ansible. Mean meaning the Mongo, Express, Angular, Node.js. I'm actually going to talk very little about mean. I'm just using it as an example app that I had a yeoman generator for that I just threw together. But the core of this is how do we take Node.js and put it in production. Okay, so just to get warmed up so I understand where people are coming from, raise your hand if you've never heard of the mean stack before. Okay, but you've heard of Node.js? Yeah? Okay, that's good. Now raise your hand if you've never heard of Ansible before her talk. Okay, good. That's fine. That's okay.
Sure.
Raise your hand if you've never heard of a configuration management tool like Puppet, Chef, Ansible, Salt.
I've heard of that.
Okay, good.
Come on now.
Yeah, this is important for me to make sure, otherwise I'm going to lose people. I don't want to lose any. Okay, so let's talk about deploying Node.js. So if you're like me, probably the first time you ever had a Node.js app, and you're like, all right, I want someone else in the world to try this, you probably went to Heroku or Nodejitsu, and you ran one of these two commands. And they magically spun up a drone for you, they do some load balancing for you. It's really nice and easy, it just works most of the time. So this is good. And in my sort of experience in working with Node for about the last 2 years or so, this is really good for sort of temporary apps, development things. I know that there are companies that use these for building large-scale deployments. We don't use them. So some of the advantage of these platforms, they tend to be pretty cheap if you're doing small deployments. If you don't have a lot of users, they might even be free, which is awesome. They're really easy to deploy. They've got great integrations with things like MongoDB and Redis, as well as things like PagerDuty and other stuff sort of keep you aware of what's going on. And you can trust Nodejitsu and Heroku to handle the scaling of your application. You throw more money at them, and they'll bring up more drones. It's great, but there are some downsides. Number one, the number of other apps that are running in that same physical box as yours is going to cause performance limitations. So it's not going to be as performant as a hardware box or your own virtual machine. Deploying to these platforms also can cause problems if NPM is down. So if part of your normal deploy process is just ship the code out, and they try to do an NPM download, and NPM's down, your deployment's going to fail. Now you can do things like NPM shrink wrap, and there's some other, I think with Nodejitsu, with their deployment, they actually, whatever you have installed locally is what they deploy in terms of your node modules. But that sort of gets, to me, that's scary. We've had problems where a module dependency, some other module's author broke Semver without telling us and changed and pulled in a different dependency. And that dependency caused a problem that rippled all the way up to our application and brought it down. So because of that, we're not using this. And I'll get to what we've done. In my opinion, there's also a bit of a vendor lock-in. You're sort of tied to one of these, either of these platforms. The two things that are most important to me, we have, in some of our applications, we want some customized applications. We're doing a lot of bandwidth intensive things where we're building a microservice architecture. We've got lots of different applications that want to talk to each other, and they're sending lots and lots of data between them. And because of that, we don't want to pay for the bandwidth between all of those. We want those applications really sitting next to on two different virtual machines in the same data center. So we're not necessarily paying for the bandwidth between them. So what do? We're doing a custom deployment. We're going to deploy to virtual machines or hardware that we own ourselves. So first things first, we need to get ourselves some servers. So you go to Amazon, Rackspace, Join, DigitalOcean, or you can go to a co-location facility, buy your own servers, plug them in, have your own IT team that manages all of them. All of that's great. Pick one, run with it. Next up, we need to set up those servers. So, as CJ was saying, you can manually craft a little snowflake of servers, which if you only have 1 or 2 servers, maybe you can get away with that. As you get to 3 or 4 or 5 servers, you realize, we really should have some scripts that we can run that, this one installs Node.js, and then this script sets up permissions, and this one sets up firewall rules. So you can build your sort of collection of bash scripts that do that for you, and each one is still slightly less of a unique snowflake. But as you get to larger and larger systems, or if you've got a persistent platform, you really want to have some form of configuration management. configuration management makes sure that all of your database VMs are identical. Or at least if they're the same version, if you're rolling out different products, you can make sure that each class is going to be exactly the same. And you can in fact prove that they're exactly the same. That's what configuration management gets for you. So earlier I asked who's heard of Puppet or Chef or Salt or Ansible. These are four probably the most popular configuration management ones. I think Puppet and Chef probably are up there in like largest number of installs. We did a quick evaluation of Puppet, Chef, and Ansible about a year and a half ago. And we spent about a half day playing with each one, seeing how quickly we could bring up a couple of servers, get them configured for what we wanted. The only one that we were able to successfully do that in was Ansible. All the other ones we failed miserably. Even when we went to a full day, it became just a nightmare of all specific terminology and language. Ansible is awesome. We love it. I know NPM is using it. Yep, so NPM is using it. Rackspace is using it. There's lots and lots of companies that are now using it to handle their large-scale deployments. So Ansible likes to say that they are an open source software platform for configuring and managing computers. And they go one step further. They say it's an orchestration engine. Not only can you use this for managing the software that's on the systems, but you can use Ansible to manage your entire infrastructure. So you can kind of think of it as it's your infrastructure as code or infrastructure as data. You define how you want your infrastructure to exist, and Ansible will go make that happen for you. So some of the reasons that we picked Ansible. Number one, it was easy to learn. We're a small team, 3 people. We don't have a dedicated DevOps person. We would like to have one. So it's important for us to make sure that we can quickly, the whole team can learn and understand the platform so that any one of us at any time can do deployments. Ansible has a ton of built-in modules. And by module, I mean something as like apt on Ubuntu. So installing packages. There's a module in Ansible that handles that. There's a module for creating and moving files or editing permissions of files. There are things for DigitalOcean and Rackspace and Amazon for doing deployment of VMs, creating virtual machines, deleting virtual machines. All of that is built into Ansible. And then because it's Python under the hood, which we have background with, if we wanted to write new modules, which we have written some specific modules, we can write them ourselves and add them into the system. We didn't have any Ruby background, so that sort of threw out some of the other ones as well. The two most important things for us, the first one that was generally unique to Ansible was that Ansible uses existing SSH infrastructure. So Puppet and Chef, you have to install their special software on each machine that you want to manage before you can actually manage that machine. Ansible just SSHs into the box with your existing SSH keys. So A, it's secure as SSH is. You're not trusting someone else's infrastructure or security protocol, which I think you said Salt does. Yeah. I didn't know that, so I'm glad we didn't go with Salt. So this is really important for 2 reasons. One, it allows us to bring up a VM with Rackspace or Amazon or Join that's pre-configured with an SSH key, and we can immediately run pushing data from Ansible into this box to get it configured and set up. The last item, which for folks that are not really familiar with configuration tools, is idempotence. Idempotence is the idea that you can run a set of commands to configure a system over and over and over again. And if it doesn't need to make changes, it won't make any changes. Does that make sense? Does that anyone not make, like, should I do that again? Okay, that's an important item.
What's the scenario?
Well, so, for example, let's say you are setting up, I'm trying to give an example, creating user accounts. So when you are setting up user accounts, you don't want to, I think you potentially could create multiple user accounts that each one has the same name, but has a different ID, which might cause problems. So you really want to check to see if that account called Fred already exists. If Fred already exists, don't create the account. Otherwise you'll end up with duplicates. And that could include things like moving files around, or uploading, installing packages, or things like restarting services. So if you know that you haven't made any changes to your configuration file, then don't restart Nginx, or don't restart your application. Okay, so outside of Ansible, we have continuous integration. The biggest things for us is, in terms of deploying Node.js, is probably this item, building Debian packages. So early when I talked about sort of that NPM downtime and how do we handle packages and dependencies, and how dependencies may change over time. We build, each time we have a change to a software package in GitHub, we run our tests and then we build a Debian package. So we do an npm install which gets all of the things that we want. We run all of our tests against that. So we verify that that complete package works exactly as we wanted. And then we bundle that into a Debian install file, which then we have that as a build artifact. That represents a complete passing build, which includes all of our node modules running again. What's great about that is we can then ship that Debian package around to any one of our VMs and install it, and we know it's going to work. We don't rely on npm at deployment time as to whether or not that box is going to come up. And that's really important because I don't trust any other service. I don't even trust our own services. Things go down. That's the nature of the beast. But by having a self-contained package which represents an entire installed application, including all of the configurations, so like if there's etc config files for it, they include database username and passwords, they include all of the our application code, as well as all of Node modules ready to go. That's probably the biggest thing for us. And then those artifacts are pushed out and deployed by Ansible. So for this example application, I found it's just a simple to-do app, AngularJS app. So we're going to deploy a MongoDB server. We're going to have 2 or more Node.js to-do app servers. And then we've got an Nginx server that's going to be doing our node methods. Okay, so let's do a quick Ansible tutorial because I was talking about how easy it is. Let me make this, I can make this a little bit bigger. So Ansible has this idea of plays, which are a set of actions that you can do on a system. This example here is a series of plays for installing Node.js onto an Ubuntu system. First thing for us, we're using Chris Lay's repo, which are PPA, which contains the latest stable 0.10 software. This is maybe, you could argue, well, you're relying on this repo to be up. Well, we're going to have to install a bunch of app packages. So if that's down, we're kind of screwed. So this is not perfect, but this is getting better. So here, this task has a name. Add node to our apt repo. And this apt_repository, that is an Ansible module. It's a module specifically for managing apt repositories on an Ubuntu box. In this case, we're saying the repo is this PPA Chris Lay Node.js, state present, meaning we want this to exist in our apt repository on this local system. If it's not present, then it'll go download that, check all of the keys and other magic stuff that it needs to do, and it'll be done. If it already exists, this step doesn't do anything. But one thing that it does do is update cache. It's going to make sure, it's going to do an apt-get update to make sure that we have our latest packages. Then the next task is to install Node. The module is called apt. The package we want to install is called Node.js. And state equals presence. So behind the scenes, this is doing apt-get space install space Node.js. What's great about this, again, is this state present. We're making sure that if the package is not installed, install it. If it is installed, don't do anything. We could put here state equals update. What that'll mean is if this version is not, that the version that's installed is not the latest version, go get the latest version and install it. We've elected not to do that because we're concerned about this Chris Lay version suddenly changing. So once this host is up, we don't want its node version to change just behind the scenes. We do have to keep track of this over multiple hosts as we deploy lots of systems in case the version does go. And the last thing, we have a list of global packages that we can install. In this case, I'm using Forever, so I make sure that Forever is installed globally. So there is an npm Ansible module, which allows you to specify that we want this package to be installed globally. The name is going to be item with items Node.js global packages. This Node.js global packages is just an array. I'm going to define a variable elsewhere in Ansible. Any questions about this so far? Yes?
Can you specify a version of the Node.js PPA that you pull in? That way you don't have to worry about the host like pulling in like some new stuff,
You know, that's a good question.
like 0.10.9 or whatever.
I don't know the answer. That's a good question. It's one that we should probably look at. Again,
When you deploy the Debian packages to all your servers, do you run your own apt repo to deploy those, or do you SCP like the Debian package over and then install it like with the dpkg command or whatever?
so we manually SSH over that Debian file and then install it. For now, we are getting to the point where we have lots of Debian packages, and we will probably start running our own internal repo that we have in each data center, which would also make the ability to do updates as well a little bit easier. We'll probably make changes. In this example, we're not actually going to be doing the Debian. In this example, I just tarred up the Node.js application, which is not as ideal, but it does include all of the Node modules, so it's still a package. Okay. So that was a series of tasks for deploying a Node.js platform. Ooh, I have a typo here. Good, I love typos. So, so playbooks, actually, let me fix this typo. I don't want to make this mistake. There we go. That's fixed. So, sorry.
Whoa. Oh. Sorry.
Chair down.
So we've learned to not lean back in chairs tonight.
I'm not leaning back there for
You get a stool now.
Do you want to switch to a seat behind you?
That's fine.
You're okay. Minor technology difference. Okay, so
It's not running Node.js.
So on the previous slide, we defined these steps. This is what it means to deploy Node.js to an Ubuntu machine using Ansible. With Ansible, you can then break down and say that whole thing, that's a playbook. And we can reuse playbooks and actually create roles out of them. And these are reusable roles. So, for example, here down at the bottom, this is a playbook for configuring and deploying a Node.js app. We specify which hosts we want this to deploy on. So I have a set of hosts called app.prod. We'll get to that. We specify which user to be SSHing into. So in this case, I'm using root. And then we specify which roles or which additional playbooks to run. The first one we're going to run is common. For us, our common are things like install Emacs, so the Emacs is on there. Set up all of the SSH keys for our team, so that any one of the members can SSH in. Setting up basic IP table firewall rules to block off the system accordingly. Other things like that. The next one that'll run is Node.js. So that'll run this previous playbook. So when this is done, we know that we have Node.js on the system. Then the last step is to install this specific application. So we have a role for each one of our applications, which represents the unique install process for that application. We also have up here the role for configuring the Nginx server. Specifically, we have a common role. We run it again, so that's consistent across all of our platforms. And then we run the Nginx specific platform. Now, one of the really nice things about having this common role is that if we need to make a change system-wide, like for example, changing all of our SSL keys, or SSL certs, or if we want to revoke an SSH cert for an individual, we can do that. We make one change in our Ansible common playbook, change one file to be whatever we want it to be. We rerun this set of playbooks across our entire host infrastructure. In 5 or 10 minutes, we've made that change across all of our hosts. We don't have to go in and make sure, manually check each one. We know Ansible will give us this nice, pretty output of all the systems it made changes on, and all the ones that it didn't make changes on. That's one of the great parts about having a configuration management tool. Ansible is just one of them like that. So, inventory. So, here we set up, I specify which hosts I want this to run. Now, you can set up your inventory to be a list of IP addresses, or host names if you want. So here I've defined app.prod. Did I use app.prod here? I did. Nice. App.prod here is my hosts. App.prod are some magical IP addresses. So if I manually provision some VMs, I know their IP addresses, I can stick it in my inventory file and I can use that. That's okay if you have a small number of hosts. But as you get to a larger number of hosts, this becomes a giant pain in the butt. So, this is out of order. That's all right. So, dynamic inventory. So one of the cool things that you can do with Ansible is you can specify your inventory as being dynamic. What that means is, in this case, I'm going to pull my inventory from DigitalOcean. So I'm going to query DigitalOcean from my account and pull in all of the virtual machines that I have running, including their name, where they're located, their IP addresses, all of the information about them, and that becomes my inventory. So now if VMs change, I know they're named or grouped accordingly. DigitalOcean will feed in Ansible, and then Ansible will then run those commands against those machines. We'll actually go backwards and go through this again. Okay. So one of the things you can do with Ansible is provision your infrastructure with Ansible. So Ansible has modules for. So there's a DigitalOcean module that allows you to create virtual machines, delete them, destroy them. There's also Rackspace, there's Joyent, there's AWS, OpenStack. There's a long laundry list of plugins that allow you to define programmatically what your infrastructure is going to look like. So for example, in the example code that I'm going to run through, I have set up a variable called droplets, which represents my 3 droplets that I want to build. Each one's going to be named production.nginx1, production app1, production MongoDB1. If we wanted to build, if we realized we wanted to scale up, it's just a question of adding some additional production.app.2, production.app.3. The next time we run the playbook, Ansible will say, hey, we don't have, it'll query DigitalOcean, say, hey, we don't have production app2 and app.3. Please create DigitalOcean, create these 2 VMs. When they're done, we're going to run the common playbook against them, we're going to run the install Node.js playbook, and then finally, we're going to install our application onto it. So, then you get a nice pretty output like this. Okay, so let's look at the code. Have I lost anyone yet? I know I'm sort of jumping and flying over. Okay, so. Okay. So this site.yaml in Ansible is our top-level playbook. It encompasses all of the things that we want to do. You'll notice the first thing that's here that we call is include this provision DigitalOcean. It's this file. So this playbook will run on my local host. The reason is my local host is the computer that's going to be talking to DigitalOcean. We set up some var files, which basically load in keys. This is the ID of my SSH key in my DigitalOcean account. Found it through the API. And then droplets.yaml. That's this file. So we're setting up these variables to use them. And then we specify we want to run this task. Please run create droplet.yaml. And then we're passing in droplets is equal to this droplets variable we defined. So what does create droplet look like? So we're saying DigitalOcean, we would like the state to be present. We want these things to exist. The command is droplet, which as opposed to network or image. Name is item.name. Item being with items droplets. So each of these droplets has a name. That's going to be dropped into here. So the name that the VM will have in DigitalOcean will be the name that we say. SSH key is the default key that we defined. Here's the default key. And then optionally, I can configure the size, region, and image for each of those that are in droplets. So if I wanted to, I could say that I want this to be in New York 1 as opposed to San Francisco or wherever. In this case, I'm just saying put them in whatever the default is. I am enabling private networking so that all my VMs are connected to the internal private network. I'm specifying a wait timeout, which means I want this playbook to pause until the VM fully comes up. And I'm also saying I want the VMs to have unique names. So if there's a conflict, that's okay. That's the exist presence equals true. And then register droplet, which then basically says all of the information about that VM, make that available to Ansible. Does that make sense so far? Okay. So let's show what that looks like. So here's my Ansible. So I've got my Ghost blog running, and I've got production, Nginx 1, app 1, MongoDB 1. So you can run Ansible playbook, provision. Can you see this already? Maybe it's a little bigger. And then I specify my inventory as hosts. So what this is going to do is going to go read that file, and it's going to go find out what is our status. Great, so it went through DigitalOcean, realized that all three of these VMs are there, so it's done. Well, for the sake of tonight, let's do some live stuff. Let's add a new app server. Let's rerun it. Cool. So it's all building a VM now. So if we refresh this, we'll see production app 2 is currently building. Okay. We'll come back to that. We'll let that run. Hopefully they're usually fast, usually less than 60 seconds. So let's move on. So that's the provisioning step. Let's go back to our site.yaml. Let's close out this other stuff. So we know by the end of this first step, all of the VMs that we defined in our droplets.yaml will exist. Now we're going to move on to each of our sections. So this first section is setting up MongoDB. Hosts production.mongodb.star. That hosts is dynamically loaded by the dynamic inventory. So first step that Ansible will do is go query DigitalOcean and find all of the names of our VMs. And any VMs that are called production.mongodb.whatever, so it's a regex query, will run this set of things. So user root, gather facts true. Gather facts means go find out all of the IP address information about this VM, go find out which version of, or what operating system, which version of that, which version of Python is installed, all sorts of cool fact information. We're pulling in some var files. So in this case, we're looking at vars database.yaml. So I created a very secure DB name, node-to-do, the user and password. So that's what's going to be how MongoDB is going to be configured and set up with. And then we run two sets of tasks. First, we're going to specifically add MongoDB into a group called production.mongodb. And the reason we're doing that is we need to make sure that our Node.js app knows about all of our databases. So that's sort of setting up, hey, we're creating a special group called production.mongodb that we're going to use later. And we also set the database IP address. So I set up the private IP address, private network infrastructure. I want to make sure that our Node.js application queries MongoDB over the private network. So we're not accessing the public network, which we might have to pay for the data for. Now we're going through the backend IP address network, which most cloud providers don't make you pay for, which is good. I don't like paying for things I don't have to pay for. So in this case, I'm saying, hey, Ansible eth1 tells me when I do gather facts, Ansible gives me a whole bunch of information about each host. In this case, I'm asking for eth1, which is the second network interface, which is going to be the private IP address. And I'm asking for the IPv4 address. I could ask for the IPv6 address, or the subnet, or any other networking information you might run. Finally, we run common, and then we run MongoDB. So I'll quickly show you the MongoDB playbook. This is it. So the first couple of things are really just setting up and installing MongoDB. So in order to grab the latest, this is literally the first, These things are all straight out of mongodb.org on how to install the latest stable version. In this case, I'm just running a specific command. I'm telling I want this directory MongoDB path to be defined, and I want it to be a directory. And here, probably the most important thing is I copy over mongod.conf.j2, which is a template, into this destination. Now, templates are cool because this is a template file, and this is using Jinja, which is a Python templating engine, which basically allows you to do variable inserts. So here I'm saying the log path, we want it to be Mongo log path, which I've defined as a variable somewhere. I forget where I defined it. Here it is. I can reuse these variables everywhere. These variables could also be defined in the top level. So even if I have different sets of types of MongoDB servers, I could have common shared variables across all of them.
How do you debug this stuff?
How do you debug it?
Yeah, like let's say that something is not going like it's supposed to.
So I usually will start with just one VM. So I'll sort of test a single playbook. And there are debug commands that you can run.
Okay.
So you can see the output of any given command. And you can also, there are also like print statements. So you can print a random variable anywhere through your playbook. It's a good question. I would say that it's not as easy as, you can't just run GDB and iterate step through. Actually, I think you can iteratively step through all the tasks. I don't think I've ever bothered to do that. Usually it's pretty obvious to me, oh, this VM can't talk to that VM because when I go look at the configuration file on the actual host, I realize that the host name or the IP address is blank. It's like, well, why is IP address blank? Oh, I asked for E2 instead of E1. So, but sometimes on more complex playbooks, it can become challenging to sort of debug. It's not perfect. I'll be the first to admit that it's not perfect. How is our deploy? Oh, good, it's done. So here we've got a Node.js app and then our Nginx configuration. I'm not going to go through all of these. All this is up on GitHub, and I'd be happy to talk with it in more detail. What I do want to show is now that we've got this new VM, let's run our whole playbook. See what happens. So first things first, we're going to make sure that all of our VMs exist. I'll move this up so everyone can see what we're doing. Now it's going to go through our MongoDB configuration and make sure that everything is just right. And we'll just reflect this one. Once this is done, that's really all I have. So I'll go ahead and jump into questions while this is running.
Why are some changing and some are okay?
Mostly because I didn't write this playbook perfectly well. So for example, the chounder, let's go take a look. For example, you can run one-off commands, like this one, that will execute that command and it will always come back as being changed, even if the command didn't do anything.
Mm-hmm.
You could write a wrapper around this, which basically recognizes that nothing has actually changed. I really should have used the act module for this, which then would tell me whether or not there was a change.
Okay.
I was sort of lazy when I was putting this together last week for the next video, and just use command. So command is just runs whatever you put it in, runs it in the shell, and it comes back with a result. I should also note that if for some reason that this command fails, so it returns with a return code of non-zero, then this host will get removed from the rest of the place. And you have a choice of maybe you want the whole thing to stop. Like, just stop. Something went wrong. Let me look at it. Or it might be, hey, this one thing failed, so let's take the host out of the rotation. Take it out of the load balancer. Let the rest of them finish. So that's something that you can decide what to do as a Ansible playbook developer.
Start with like Heroku or NodeJS or whatever and switch because of some specific pain point or feature set or whatever.
In terms of sort of before we made the full jump into Node.js for sort of our application infrastructure, we played around with Ansible or Heroku and NodeJS really for sort of example apps. The first application that we needed to build with Node.js had an existing infrastructure that really needed to run specifically in a true VPS platform. It was an embedded real-time system that ran in CentOS that was real picky, and so we needed to custom build an image that ran in a provider. And because we're doing, that platform was doing lots and lots of audio, which is very bandwidth and CPU intensive, and Node.js was going to be touching pieces of that. We decided to put our entire infrastructure next to those sort of special VMs, which then meant, okay, now we have to figure out how to run Node.js in an existing Rackspace or AWS infrastructure. So then it was like, okay, well, we don't want to write a bunch of bash scripts. Let's look at Puppet, Chef, and Ansible, and that's we sort of found Ansible 2 years ago.
So if you had more standard like CRUD application, even if it was really high traffic, would you have gone down this route, or would you have gone down a different route?
You know, that's a good question. I have a hunch. I'm a bit of a control freak, and I have a hunch that we would have likely eventually moved over to our own hosting platform. Maybe we would have lasted longer. Maybe we've done V1 and V2 entirely on Heroku or Ninjitsu. But I like having control of the underlying security of the platform, knowing exactly how it's configured. It means it's a trade-off, right? So by doing that, you now own your entire infrastructure, and so it means you pay more in terms of salary of your team to manage that, instead of paying someone else to do that for you. It's a trade-off. I think we likely would have eventually switched over to a pure hosting platform anyways, but maybe that's just me being control freak. Yes?
More of a FYI, I guess. That whole thing with the npm shrink wrap and the tarball, and in the most recent version of SLC, which is the open source command line tool, we put in like a bunch of commands called build and publish to like solve exactly that. So if anyone needs that, like just go grab that open source module and try that out.
And so what is it doing behind the scenes?
It's just tarring the right stuff up, but it has logic to hit the right stuff. So like exclude binary things, and then when you publish, on the other side, it knows that you excluded binary things and gets them and then builds them. It just it doesn't do anything magic, it just does the stuff you would have wanted to do.
It actually does, so it finished. Yay! So in theory, we can go find our Nginx IP address. Yay! There it is. And in theory, we can tear down app servers and it's still. Oh, that was actually, that was one of the cool things about. Let's take a look at the Nginx. So Nginx does the load balancing for us. This is our configuration file for the upstream. So we set up a server to listen on port 80. And we're saying proxy pass, we want everything to go through to this proxy called static, which undefined up here is static. And what we're doing is we're iterating over all of our Ansible hosts that have the name production.app. And for each one of them, we're specifying a server here as that host's IP address, port 88. So we're querying DigitalOcean, we're looking at all of the hosts that have production.app as the host name, and then we're updating Nginx, its configuration to include that host in the load balancing pool. So if we were to delete a server, we would see that IP address, the next time we run the Nginx playbook, it would then remove that host from the list. And I can show that, actually. So we SSH in here. So here we have 1028, 190.9, and 128.8. Those should be the internal IP addresses of production app.1. What does it tell us access? There it is. 1028, 128, 190.9. That one. So if we were to come in here and say, let's destroy, it's not while I'm scrubbing. Let's destroy production.app.1. And actually, in theory, I should have edited my droplets directly and gotten rid of this. So that's being destroyed. Now 50% of our HTTP gets are failing, which is bad. We can rerun our playbook now, which we'll go find out about our hosts. And we'll then update Nginx, and we'll then update that. If you were doing this the right way, the creation and destroy of your droplets or your VMs would be done entirely based on this one file. So it would be smart enough to know, hey, this VM exists in DigitalOcean, but it's not in our var file, so let's get rid of it. I didn't put that together for this, but that would be the right way. Or in theory, because with Ansible you can pass in variables from the command line, probably what we're going to do in our next iteration is Jenkins, as part of our Jenkins configuration, will list our infrastructure. And Jenkins will then send a variable via the command line to Ansible saying, here's the host that we want to exist. Or it could even be something that's checked in the Git. So a developer can just make a commit to a Git repo, which includes our infrastructure. That triggers a build on Jenkins. Jenkins then runs Ansible to go create the VMs, which will then rerun all the configuration and deployment and Nginx configuration. Questions?
So you used this DigitalOcean, right? Similarly, there must be some way to use the web servers, like other web servers, like others.
Yeah, so there's,
So the tag be first, right? Basically.
yeah, so let's go take a look at Ansible docs. There's a long list of them.
Not Wi-Fi.
Module index. Cloud modules.
If you want to install a specific version of Nginx,
You do it the same way with the APT, you can specify which version. So as long as it's available to your APT get, then you can, as part of the APT install command, you can do that. So there's DigitalOcean, Azure, CloudFormation.
I see that there's
There's Docker stuff, so if you want to manage Docker containers, you can.
you try it with Docker.
I have not played with Docker yet with Ansible. We are evaluating Docker as a new way of doing our development sandbox and test infrastructure. And that's probably where we'll test Docker first. And we'll use Ansible to do that. So check back with me in a month or two and I may have more to say about Docker. I've played a little bit with Docker just on personal projects, but nothing serious. So. You had a question?
I was actually going to ask you, in your choice of using Debian packages, if you had instead considered using something like Docker, which provides a more complete package, but I guess you have considered it.
So when we first got down this road, Docker didn't exist.
Right now.
And so we've continued to, we're small teams, so we have to pick and choose which newfangled technologies to play with. Usually it ends up, if the way we work, we occasionally will just say a half day on a Friday is just go do whatever you want today. Just one Friday or a month or whatever. And that's usually when we go play with new stuff. So at some point we'll play with Docker. Other questions? Cool. Well, thank you for letting me bore you for a while.